Okay, that's day 4 in the final revision for the May 2023 Chemistry IGCSE 0620 exam. So I have received a lot of questions about the isomers, so I'll be dedicating most of the time here for the isomers. And before answering these questions and watching the video, I please ask you to be sure of yourself in the naming compounds. Start to see the video about the naming compounds and try to answer the questions only after doing that. Otherwise, it will be a little difficult job in the isomers. After that, we will start our questions. We'll start with easy ones first and work our way up. So our first question here is asking if compounds 1 and 2 are isomers. The first one is an alkene. I can see 1, 2, 3, 4, 5 carbons, and I can see that there is no double bond. So this is an alkene, pentane. The other one is 1, 2, 3, 4, 5, 6 carbon atoms, and there is a double bond. There is no way that 1 and 2 will be isomers. Why? They don't have the general formula. Alkene and alkene, they don't have the general formula, so it's impossible for them to have the same molecular formula. And this is the condition of having isomers. They should have the same molecular formula, have the same number of carbon atoms and hydrogen atoms. So if it's CnH2n and CnH2n plus 2, this one will always be more than the alkene by 2 hydrogens. So they will never have the molecular formula. So they will never be the same molecular formula and never be the same isomers. Besides, there is different number of carbon atoms. If even they are not the same, like they are both alkanes, then one of them has 5 carbons and one is 6 carbons, so it will never be, they will never be isomers. If we looked at the molecule number 1 and molecule number 3, are these two isomers? Let's see how many carbon atoms and hydrogen atoms are there. If we counted the carbon 1, 2, 3, 4, 5, and here 1, 2, 3, 4, 5. The hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Apparently they have the same molecular formula and different structural formula. The structure is different because the main chain here is 1, 2, 3, 4, 5, but the main chain here is 1, 2, 3, 4. However, you try to count the main chain, it will never be more than 4. So 1, 2, 3 here, 1, 2, 3, 4. While here it was 5. Actually, let's start learning that in order to make an isomer in alkenes, the only way that you can do that is that you can just change the number of the carbon atoms in the main branch. You cannot change the position of any functional group because the functional group is only C single bond C, and this cannot be changed. So the only way to make isomer here in alkenes is just to change the number of carbon atoms. So if you have 1, 2, 3, 4, 5, try make it 4 or 3 and then make branches, but at the end the number of carbon atoms should be the same. So these two compounds will have the same molecular formula and different structural formula, so they are isomers. Okay, what about this one? Number 1 and 4. We are having different structural formula, but different molecular formula as well. Because as we said, this is 1, 2, 3, 4, 5, and here 1, 2, 3, 4, 5, 6. So this is totally not isomers. Again, 2 and 3, they are not isomers. One of them alkene, one of them alkene. So if they are different homologous series, they will be different molecular formula for sure, and of course different structural formula, so they are not isomers. So that was the question that came in the past paper. Which two compounds are structural isomers? We can see clearly that in order to make isomers here in alkene fast in the exam, you can do this only by branching, which means the two compounds that you will choose and they are both alkenes. You cannot choose one which is alkene and one is alkene, so 2 is removed completely. You can only choose 1 and 3 or 1 and 4. So we have to choose two that they have the same number of carbon atoms and hydrogen atoms in total, but the main branch will be having different number of carbon atoms. This means that they are one of them is branched and one is non-branched. The first one has 1, 2, 3, 4, 5 carbons in the main branch, and the second one, number 3, has 1, 2, 3, 4 only in the main branch. Of course, both of them should be alkenes at the end. That make it easy. Alkenes, only by branching you can make the other isomer.